Okay. Hello, everyone. By the way, if you're comfortable, you're welcome to get closer. This is a big room, and I don't bite. I don't know about you. So, important thing first, there's still a chance to enter the raffle for a Nintendo Switch. So, make sure to scan this. There will be another slide in the end with this QR code if you missed this. Okay, yeah, so I'll start with a stupid question. Who here uses AI to generate code? Okay, yeah, just as I expected. 90% probably. Okay, now who runs that code in Sandboxes? 2 or 3 very hesitant hands. Okay, now who knows what AI sandboxing is? Okay, a bit more, fine. Now an important question. Who here trusts AI agents? Okay, okay. Thank you. So that's good. That proves my theory. We don't trust AI agents. Right? We know they can be hallucinating, right? And the code they generate sometimes reinvents wheels instead of using, libraries that are battle tested. And also they're very prone to attacks such as prompt injections. And in general, they can attempt to do some weird stuff, right? Now, on the other hand, we all seem to use them to generate the code, right? And we need to use that code. In general, the way it looks now, pretty soon we won't have any other code to use, right, than the code they generate. And overall, we also want our agents to be autonomous, right? We want them to be able to access APIs. We want them to be able to write and read files, maybe provision infrastructure, maybe database transactions, right? So all very useful, but potentially also very destructive stuff. So how do we allow them to use all that, but still, be able to trust them with that? Well, the answer seems to be we need to isolate them. Now, we're here at a Cloud Native Summit, right? And we actually already have an isolation technology in the Cloud Native ecosystem, right? Anybody heard of containers? But the notion seems to be that containers are not good enough for AI sandboxing. And why is that? Well, because containers are not very secure by default, right? But on the other hand, we all know that containers can be hardened, right? There are technologies to harden containers. We can isolate them with capabilities. There are user namespaces that can be used. And of course, when we're running on Kubernetes, we can use network policies to isolate the networking. And moreover, we could even use kernel filters, right? But, well, there's that thing, all containers are sharing the host kernel, and that seems to make them prone to specific attacks that allow to break out and take over the kernel. For example, user namespacing can actually help with that attack because it provides a fake root, and that can help with some network attacks. So, yeah, but by the way, on the other hand, seccomp filters could help with that, could prevent that, but who here has seccomp enabled on their Kubernetes nodes? Okay. Much less hands than the folks who generate code with AI agents. Okay, yeah, there was a talk by Constance previously, and she said that probably 1% usage of kernel filters in general over the industry. So the notion seems to be that containers are not secure enough to run code generated by AI, right? Or rather that hardening containers is so excruciatingly hard that we're not ready to do that. So what do we do instead? How do we isolate our agents? Maybe we should go back to good old VMs, right? So how do we use VMs but without the overhead of the VM? Well, the answer seems to be micro VMs. Okay, anybody here using micro VMs? No, okay. Now, the technology, who heard about micro VMs? Okay, yeah, the technology has been around for a long time. Basically, well, the main technologies for running and creating micro VMs seem to be, well, today it's Cloud Hypervisor, right? Created by Intel in 2019. Firecracker created by AWS in 2018. And at a certain point, Camo also decided they need to support micro VMs, so we also have Camo micro VMs. By the way, Firecracker was originally forked from a project by Google that was called CrossVM, that was created for virtualization on the Chrome OS, and that was written in Rust. And then there is this set of libraries called Rust VMM that was taken out of Firecracker, and then Cloud Hypervisor was created on top of that. So there is a reason for that, of course, because Rust is highly performant and memory safe. And by the way, if you're interested in how Rust is becoming a leading language for today's AI native era, we're having a webinar a week from now, so you can scan that and sign up for the webinar. We're doing that with the Rust Foundation, and we'll be talking about how to convert your code bases to Rust. Now, micro VMs. So basically all it involves is using that virtual machine monitor or a VMM, probably written in Rust, Cloud Hypervisor, or Firecracker. Now, we actually want to do this on the cloud, right? We're in a cloud native summit. So how is that possible on Kubernetes? There is a project called Kata Containers that's also been around for 8-9 years that allows to replace the container runtime, the standard container runtime, which is usually containerd today on Kubernetes, with a virtual machine monitor. So it integrates with either Hypervisor, Firecracker, or Camel, and then it runs each pod in a micro virtual machine, right? And that provides us with better isolation, and that allows us to create sandboxes that are probably more secure than containers, right? Well, that's, by the way, another question. Are they actually more secure? Do they actually provide the needed isolation? Because, you know, okay, one of the attacks could be accessing the host kernel, but AI can do much more of weird shit that's not related to accessing the VM at all, right? So if it cannot access the host kernel, but it can still access your database, what help is the sandbox? But the title of my talk was The Cost of Security. And I care about that because I'm here representing Perfect Scale that allows you to run Kubernetes at the lowest possible cost and the optimal performance. So let's talk about the costs. Micro VMs are more secure, more isolated, but of course they also cost more. Each micro VM is, of course, less lightweight. They're more lightweight than regular VMs, but they're less lightweight than containers. So there's the problem of cold starts. So startup speed is hundreds of milliseconds, while with containers it's milliseconds. And of course there's a memory overhead for each pod now. And there's the VMM tax. So the virtual machine monitor needs to be installed on each one of the nodes, and it also requires resources. And for us cloud native folks, there is more cost. So you cannot use all available cloud instances for this because they need to support nested virtualization. The good news is the newer generation instances actually already support, most of them already support nested virtualization out of the box, but there is still an overhead. So you cannot use the smaller instances because running a VMM requires close to 2 gigabytes of RAM and 4 cores of CPU. So that's just for starters, before you started running any container, any pods on that. Which means that for more lightweight workloads, your cluster can suddenly start costing twice as much. Okay? By the way you enable an alternative runtime on Kubernetes is a runtime class. And for example, this even allows us on Kubernetes, when we define the runtime class for Kata containers, it allows us to define that overhead. So there is a fixed overhead that says we're already paying more for the nodes even before we started running anything, and we're paying that, of course, for running AI. Okay, so we want micro VMs, we want the isolation, we want security. We probably don't want to pay twice as much. There's a middle way. Anybody here using gvisor? Okay, one hand, maybe two. So yeah, this is the middle way. Basically, gvisor is a tool that was created by Google. It allows us to run containers, but it provides an application kernel, so-called application kernel called Sentry, that intercepts all of the system calls coming from containers, and instead of sending them directly to the kernel, it translates them and thus creates another protection layer. So it's more secure, it's more lightweight, lower memory overhead, but there is an I/O tax because everything that goes to the file system is now translated, so it takes much more time to write to the disk, and some things are just not compatible because some system calls are not supported, so you need to check if this even serves the purpose you want to do. Okay, so another option, right? Now, we've seen that sandboxing on Kubernetes is possible. Sandboxing on Kubernetes is expensive. We're not sure we want to pay the tax, but we definitely want to do sandboxing. And the proof is this new project by CNCF that's called Agent Sandbox. So it also talks about the fact that, I didn't talk about, right? That sandboxing is much more than just using this or that container runtime. So it talks about how to make sandboxes possible and useful on the cloud by providing, first of all, that strong isolation, by integrating with Kata containers or gvisor. Also hibernation, so we want these sandboxes to be able to freeze and then unfreeze, do that automatic resume. Of course, the question of storage needs to be solved, and cold starts. Yeah, by the way, I was thinking that this weather actually makes cold starts sound very attractive and warm pools less attractive, but yeah, it creates warm pools of micro VMs. Another concern is agents are very reliant on memory. Memory makes them more or less useful, so we may also want to do memory sharing between sandboxes. And of course, agent identity is a question that we now need to tackle, and Agent Sandbox is supposed to support that too. And of course, we want these sandboxes to be highly programmable, like anything that runs on Kubernetes. So if you haven't heard about that, definitely worth checking out. Maybe this is something you want running in your clusters. And of course, it's an open source project, so you can join, contribute, support. Okay, and coming back to my original topic, cost. So when talking about the cost of AI, we usually talk about, the cost of GPU. There is now this new term, tokenomics, talking about how much do the tokens cost us and how much value do we actually get from these tokens. Now we see that there is more cost involved, right? The cost of sandboxing, the cost of identity, and when talking about sandboxing, the question comes back again. Is the value we're getting from AI agents really does it justify the cost of sandboxing? For example, if we're using micro VMs for sandboxing, or maybe, go back to hardening containers, pay less, get a bit less security on the OS level, and then, take care of other concerns with AI security. We don't have answers for that yet, as with many things with AI, right? We don't have answers yet. The one thing we already know, most of us generate code using AI agents, so we'll need to continue talking about that. And if you want to win a Nintendo Switch, scan the QR code on top. If you want to talk about how cloud native is slowly becoming AI native, scan this QR code and connect to me on LinkedIn. And as I said, I'm here representing Perfect Scale by Do It. What we do is we help you run Kubernetes with sandboxes, without sandboxes, at the lowest possible cost, at the optimal performance. So definitely visit our booth. Thank you for listening, and I'll take questions if you have them.